right, so today is January 10th. We are doing Chapter 4, Section 6. We are talking about things called rational numbers. All right, yes. Why don't, no, you need a ruler of your own. Get a ruler. If not, just use your grid line. All right, you need a ruler for my class at all times. Okay. All right, so when we talk about rational numbers, all right, I'm going to tell you what the definition is, and then I'm going to do a diagram for you so you can see what they are. These are numbers that you have already been using your whole life. Well, your whole life at St. Hugo's, starting in probably 3rd grade and a little before that. Well, some of them before that, some of them after that. Okay? So rational numbers are any number that can be written as a fraction, A over B, where A and B are not 0. Well, actually, B is not 0. A can be 0. So it's any number that can be written basically as a fraction. Having B as 0 is undefined, so that's not possible, because you can't have 0 things that you're splitting up. That's what that would mean. Your whole can't be 0. All right, so let's take a look at what these mean. All right, so what I want you to do is we're going to make a little picture. Draw a circle that you can write in. All right, these are called, and I'm going to do 3 circles. One's going to be inside another, so make this on the smaller side. These are called whole numbers. So I'm going to do a smaller circle and then a bigger one kind of over around it, and then a bigger one around that too. All right, whole numbers are like 0, 1, 2, 10, 463. Those are whole numbers. It's our counting numbers starting from 0. So these are whole numbers. So you've been learning these since you could learn how to count. All right. The next grouping that includes those whole numbers, these are called integers. These were introduced to you guys as that name last year. All right. Integers are like -1, -2, -463. So it's all, integers are all of our whole numbers and their negative partners. Okay. The final group, these are called rational numbers. These are called rational numbers. They include your whole numbers, they include your integers, but they also include numbers that we have missing. So I'm going to write off to the side here, rational numbers. So they are your whole numbers, they are integers, which technically are your whole numbers. All right. What are not included in the current numbers we have here? What numbers are not included? Romano? Fractions. So something like 1/2. So I'm going to put 1/2 in here. negative 1/2. All right, what else are missing from this list? Aaron? Decimals. Now, decimals are where not all decimals are rational numbers. There's only certain decimals. One type of decimal that's a rational number is called a terminating decimal. One decimal is called a terminating decimal. An example of that is 0.5, which is what 1/2 is. Why is that considered terminating? Why is 0.5 or 1/2 considered terminating decimal? Layla? Because what? It does equal a fraction, but not all fractions are going to be terminating decimals. Why is this considered a terminating decimal? Pierre, I need your thinking, please. Why is 1/2 is equal to 0.5? Why is that considered a terminating decimal? Romano? Pardon me? Well, it is half. 1/3's not a terminating decimal. 1/2 is. So to find to find the decimal equivalent of 1/2, what do we do? So if I want to know what 1/2 is as a decimal, what math do I do? We're going to talk a little bit about this today. To turn that into a decimal, what do I do? Yep. 1 divided by 2. So 1 divided by 2. Alright, so if I do 1 divided by 2, well, 2 divides into 10 5 times. What is our remainder if I do this division? What is our remainder when I do 1 divided by 2? This is the easiest question you're getting from me all day, because it's sitting right there in your face. What is my remainder? Pierre? There is a remainder. What is the remainder? 0 is our remainder. That is what a terminating decimal is. A terminating decimal is when you have a fraction and you're looking for the decimal equivalent. When you do the division, the remainder is 0. All right, well, the other kind that we have is a non-terminating repeating decimal. What fraction is, if you did the division, what fraction do you know for sure is a repeating decimal? All of you should know this. Jack? Yes, what fraction do we know is a repeating decimal? You guys should know this. 1/3. 1/3 is 0.3 repeating. That means when I do the division, I have the pattern. It keeps going. I have a pattern that it keeps repeating. All right, so a non-terminating repeating decimal, this is also considered a rational number. So the only numbers that are not considered rational numbers are non-terminating, non-repeating decimals. Those are called irrational numbers. All right, so non-terminating, non-repeating decimals. All right, that would be something like pi, right? Because doesn't ever stop, but there's no pattern to it. Okay, so these are rational numbers. Okay, let's talk about, since the whole point of this is talking about fractions. All right, so let's talk about equivalent fractions. Let's talk about equivalent fractions. Equivalent fractions means they are two or more fractions that are the same value. All right, there are two ways to create equivalent fractions. There are two ways to create equivalent fractions. The first way is to divide out common factors between numerator and denominator. So one way we could do it is to divide out common factors between a numerator and a denominator. So, for example, if I have 2/4, what common factor do 2 and 4 have? Mateo? 2. So I'm going to divide a 2 out of the numerator and a 2 out of the denominator. So I want to see you're dividing by 2 over 2. When I'm done, I have 1/2. All right. How about 12/15? What common factor do 12 and 15 have? Kira? 3. So I'm going to divide the numerator and the denominator by 3. So I end up with 4/5. How many of you guys are cool with this? Okay. The second way is to multiply numerator and denominator by the same number. Alright, so if I have 3/5, I could multiply 3/5 by 2 over 2 and get 6/10. If you notice, I'm showing multiplying the numerator and the denominator by the same number. Questions so far? Okay. So now that we know, and this hopefully is not new for you, now that we know how to change, how to look at fractions and compare fractions, all right, or we look at fractions, now we need to talk about comparing fractions, all right? So what I want to do is I want to compare numbers. All right, so to compare numbers, all the numbers must be in the same form. So all the numbers must be in the same form. All right, and then all right, they must be in the same form, and if we have fractions, the fractions must have the same denominator. The fractions must have the same denominator. So let's take a look at this. I want you to graph 1/2, -8/10, 1, and -0/2. I want you to graph them on a number line. Then order from least to greatest. All right. So we have 1/2, we have -8/10, we have 1, and we have -0.2. All right. What common denominator? So if I was to turn 0.2 into a fraction, what fraction would that be? Okay, this is kind of going back, and we're going to talk more about turning these into fractions. But what fraction would that be? That says 2/10. So what would it be? This is you guys. This should be easy for you. Jack, be more. Don't. I need exactly what this says. Don't simplify it. Give me exactly what this said. Yep, this is -2/10. How many of you guys agree with that? All right. So here is a fraction with 10 as my denominator. Here is a fraction with 10 as my denominator. I can compare those. How many of you guys agree that I could compare those? Okay, so how about 1/2? I want to create a fraction out of that with 10 as my denominator. Remember, I need a common denominator. What can I do to that 1/2 to get an equivalent fraction with 10 as my denominator? Aaron? Multiplying by 5/5. So I need to multiply my fraction by 5/5 because 2 times 5 is 10. So whatever I do to my denominator, I do the same thing to my numerator. So this is going to be 5/10. How about 1? What is that as a fraction with 10 as my denominator? Remember, this is like 1/1. Mateo? That's 10/10. I have to multiply by 10/10. So now I have my fractions that I can put on all of them on a number line. All right. So what do you suppose all of my increments, each increment should be counted in? What should I have my increments counted by? If I have all of these are in tenths. Frankie? Yeah, I'm going to count each increment is going to be a tenth, right? All right, the lowest I'm going is 8/10. The highest I'm going is 10. So I think I may need to make this a little bit longer. So let's say I'm going to go down here. This is going to be -8/10. 7, 6, 5, 4, 3, 2, 1, 0. Here's my 0. So this is -1/10. This is +1/10. And then I'm going to count up from there. So here is 10/10. So I'm going to put a dot where each of these are. So where would -2/10 be on my number line? Here's my 0. Where would -2/10 be? Angela? Excellent. Here's -2/10. I'm going to put a dot there and label that. So I've done this one, I've done this one, I've done this one. How about 5/10? Where is that going to be? Mateo? 1, 2, 3, 4, 5. Here's 5/10. So I have -8/10, comma -2/10, 5/10, and 10/10. There is an order of least to greatest. Okay, I need to adjust your homework, so get your assignment notebook out. We did not get as far as I wanted. So I want you to take 21 off. I want you to take let's see. I need you to take 32 through 36 off. Keep 37. Take 40 off. Take 42 off. Keep 43. Keep 45. So 21, 32 through 36, 40, and 42 take off. And you guys can go. Thank you. Hustle to your next class because we're a few minutes late.